Hello everyone, welcome to the course Python Fundamentals Building Blocks for Aspiring Developers. So let's get started with the course. So for the first module, we will go over some introduction for Python. So this is our agenda for the first module. Today is the first day, and in this lecture, in this video, we'll have a look at some programming concepts, overview of Python and its applications, and we will install Python and a development environment. So we'll particularly install VS Code. And in the upcoming videos, in day 2, day 3, and day 4, we will go over basic syntax, some operators, and some string manipulations. So the first module is essentially covered in 4 days or 4 lectures. So let's start with the first day 1, introduction to programming concepts. So first, what is programming? This is the first question. So what programming is? So it is a process of designing and building executable computer programs. So we have to create a program, we have to give it a set of instructions. So whatever computer program that you are using, it can be Microsoft Excel, Microsoft Word, it can be any game that you are playing, it can be Notepad, any computer program that you are using, it is created using programming. So it is the process of designing that program that users can use. So that program can help us accomplish a specific task or solve a problem. So again, there are a lot of softwares out there, all of those trying to solve one particular problem or giving us one particular feature that we can use. And we write the instructions in a programming language. So for the program that we develop, it has to do something, but we have to tell it some instructions on how to do that particular thing, what to do. So we write these instructions in a programming language. And here are some key concepts for programming that we need to understand. Now these concepts apply to all of the programming languages out there, not only Python, but all of those which are out there, except the object-oriented programming, because this is available in some programming languages but is not possible in some others. But let's go over them. So first we need to understand algorithms, then we will have to understand variables, control structures. So variables basically hold data for us. Then there are control structures which allow us to control the flow of the code. Then there are different data structures which help us to store the data in our code, if it will make sense. We will obviously go over in detail for each of these when we make a lecture on those particular things, but just for now. Then there's functions, and then there's object-oriented programming, and then there's debugging of code, that is removing the errors from our code. So first, let's try and understand algorithms. So algorithms basically are step-by-step procedures or a set of instructions or formulas that we can use to perform calculations, use to solve problems, or maybe process the data in itself. Now this set of instructions are required by a computer, and they can be very simple and they can be all the way up to being very hard. So what could be set of instructions be? Now if I give you another example other than programming, for example, you want to create a meal for you. You want to do a breakfast and you want to eat an egg. So what are the instructions that you need to follow? So first you need to take out your pan in which you're going to cook the egg. Then you're going to put it on the stove, and then you're going to turn on the flame, light the flame, then you're going to crack the egg, then you're going to put the egg in the pan, then you're going to cook the egg until it is cooked, then you take it out, turn off the flame, put out the pan. So these are like 6-7 instructions that you need to follow. So if you were to tell to someone, okay, how to make an egg, these are 6 or 7 instructions in the same order that you tell someone, okay, you follow these and you will have an egg that you can eat. So these are like algorithms. Obviously, in computers, we don't tell it how to make an egg because it cannot perform these physical tasks. But for data processing or for problem solving, we can give it a set of instructions. For example, there is an equation and we need to first add two numbers, then multiply it by 10 and then divide it by 4 and then again add 4. So these are like set of instructions. First you add two numbers, then multiply by 10, then divide by 4. So you tell computer, okay, do this step, then this, and then this. So you are giving it a set of instructions to follow. Like, okay, you need to do this to be able to have this sort of output. So this is how algorithms work. Now algorithms can also get very complex. For example, if we were to use the same example of cooking, let's say you have a very difficult recipe to make. It takes maybe 3 hours for you to cook, and there's a lot of things that you need to do. Now that is much more complex. So in terms of programming, there are different algorithms which are much more complex. Maybe we do not only need to do addition and subtraction. There's a lot of things that we need to do. So that algorithm will be a lot more complex. So what you need to understand is that algorithms basically are step-by-step procedures or instructions that you need to follow to get to an output or perform a particular task. So now let's move over to Python. So what is Python? We know that Python is a programming language. We know this by now. Now it is a high-level interpreted language, simple and readable and dynamic. Now let's go ahead and understand these terms. So there's basically two types of programming languages, high level and low level. Now the high level languages, they operate on a higher level, which means not much detail. Low level languages operate on a lower level, which means much more detail. Now these basically mean in terms of the computer components and these sort of things. For example, C++ or C, these are two different programming languages. They both are low level languages. Let's say C++. With C++, you can control much more things in the computer. For example, if we go even lower, there is assembly language, which is basically you write in zeros and ones, which electronics can understand. Electronics in your computers are RAMs, your memory cards, your hard disk, these sort of things. So in that language, in the low level languages, we can basically tell them, okay, this is the particular data. This is 010101. This is like this, because data is essentially zeros and ones in computer. So you say, okay, store this particular data bit in this particular location of the hard disk. Now this does not mean like you store it in E drive and in the folder named like Python. This is a different sort of a location. But the location in the lower level is that in this hard drive, you need to store it here. So we are really accessing the electronics with our code. So this is a lower level language. Now with Python, we do not need to specify it that, okay, this piece of data bit, you need to store it at this location in the hard drive, or you need to store it in the RAM for the moment, not in the hard drive. But we just say, okay, we have this data, that's it. Python will take care of that, of where it needs to store it. So you see, we're not really dealing with the lower level of dealing with the electronics and all that stuff, but we're just trying to write our code. So this is the difference between a higher level and a lower level language. Now it is also an interpreted language. So there's basically two types of languages, interpreted and compiled. Now in interpreted language, when we run the code runs line by line. It starts from the first line, executes the first line, moves on to the second line, executes it, then moves on to the third line, then fourth line, like in the same order that we have written. But for other languages, for example C++, which is not an interpreted language, now when we write a code, we say, okay, run this code. It will not start from the first line. It will say, okay, it will gather the complete code, it will compile it all together, and then it will say, okay, now I will run it. Now that code runs all together. So there is also a difference on how an error is displayed. Now, for example, you have an error at line 5, okay, and you run it with Python. What it will do, it will run the first line successfully. It will say, okay, it is fine. Run the second line successfully, third line, fourth line, and when it reaches on the fifth line, it will say, okay, here is an error, but it has successfully ran the previous 4 lines. You will see the output of those lines if there is any output. Okay, but if it is a compiled language, for example C++, what it will do is that you write your code, there's an error on the fifth line, you say run the code. It will not start running the code, it will combine the code all in one. It will see the code and it will say, okay, there's an error in line 5. It will not even run the first 4 lines. So you say, okay, this is the error, you correct the error, and it will again compile it and it will run it all together, but in the same order. So this is the kind of difference of how it is executed by our programs. Then it is simple and readable, which means easier to read syntax. There are a set of rules in which we have to write code. For example, we have to put a colon or a semicolon, we have to write something in brackets. So there are a lot of rules out there. So different languages have different rules. Some have much more rules, which can be difficult to read. Some have less rules or simple rules like Python, which are easier to read. Like when you have a piece of code there, you can simply read and you say, okay, this is happening here. Okay, and then it is dynamic, which means we can change different data throughout the code. We will have a look at this once we perform something practically. So there are also some key features for Python. Again, easy to read syntax, as we discussed, interpretive and interactive. Again, now there's an extensive standard library. Now this is also important because when we install Python, there's a lot of things that already come pre-installed, like a lot of basic functions. For example, addition, subtraction, multiplication, exponential, let's say slicing the data, let's say dividing your text into two. For example, you have a text that says I love Python and you want to divide this into two equal parts according to the alphabets. So there are like 5 and 6, ILOVEPYTHO, and there's 11 alphabets. You say, okay, divide these into two equal parts. In the first one you have 5, in the second one you have 6. So there is these sort of basic functions already there. You do not have to develop them yourselves. In some languages there are not as many functions there, like even for some basic functions you have to write the code yourself and then you have to use it. But for Python there's a lot of them out there. It will also be much more clear when we start coding. Then it's cross-platform, which means that we can use Python on different platforms, different operating systems, Windows, Mac OS, Linux, on servers, all that stuff. So this means that if you write a code on one machine, you can pretty much run it on every other operating system. You can share the code easily and different people can use your code. Then it also has a lot of community support. Now this is really important because it is really helpful if we have a bigger community. So what basically a community is, that is the number of users who are using Python. So Python is a very popular language, so a lot of people around the world are using it. They make different codes, they make different programs in Python, and then if they run into a problem, let's say someone says, okay, I have this problem, I cannot solve it. They post it on the internet and they ask for help. Now a lot of other people are developing in Python. Some might have encountered the same problem, or they know the solution to this problem. They will simply answer that person, okay, this is how you can solve the problem. So that person does not know the person who has answered him, but he can still get an answer. He can solve the problem. So this is how a lot of community can help in coding. So if you run into a problem, if you want to learn something new, you want to see what is going on. There's a lot of stuff out there on the internet relating to Python that you can always have a look at, and it will be easy for you to search for different things. And then finally, it has object-oriented support. A lot of languages do not have it, but Python has it, and we will look this in detail when we reach to that module. So there's a ton of applications for Python out there. As you can see, it pretty much allows us to do anything. Scripting and automation. Again, you have a lot of tasks. Let's say you want to perform the same task on 200 files. Just write the code in Python. It will perform the same task on those 200 files, and you won't have to do it manually. Now, same is the case for some softwares out there. They do provide this support for Python automation. Like you have a software, for example, let's say Adobe Photoshop. So you have to, let's say, edit 200 photos of the same style. But instead of doing it manually, you quickly write a script or a code in Python within the um, within the within the program Adobe Photoshop, and you say, okay, process these files, and for the 200 files, it will process them. So instead of doing it manually, it does the job for you. Then it is applications in data science and machine learning. So this is also one of the main features of Python, because it is mostly used for data science and machine learning due to its functionality. Then we have web development. Although not a lot of websites are developed in Python, but still it is now gaining a bit of popularity, and there's a lot of functionality coming out in Python that supports web development. So we can, of course, create a website in Python. And then there is game development, creating different games, and there are desktop GUI applications. So these are graphical user interface applications, so which have a user interface, for example, dialog box, different buttons out there. So you don't have to interact with the code, you just interact with the interface, and it does the job for you. So you can create those in Python too. So now let's set up the environment that we will be working on during this course. So for this, we basically need two things. We need Python, and we need a software, which is an interpreter. So interpreter is basically a software. So interpreter basically reads the code that we have written, because it is not in plain English. It is a different syntax. So the interpreter knows what the code means, and it will run the code for us. So there's a lot of interpreters out there, and interpreters are basically softwares too. So there's a lot of interpreters out there for Python. Um, there's VSCode, there's Sublime Text, there's Notepad++, and so on. But we will be using VSCode. Why? Because it has a large community, it has a lot of functionality, and it is easy to use for beginners. So let's get going. So the first thing I will do is that I will copy this link, and I will go here. Let's hit enter. So this is the Python page. Here you can find different versions of Python. Now I would suggest here that you do not install the latest one, because sometimes the latest one has some bugs or some small errors. So when the latest one is released, a lot of people use it, then they report it, and in the next versions they fix it. So it is better to use one or two versions prior to the latest one. So for this one, what we will do is that we will use Python 3.8. And now why we'll use Python 3.8 is because I have already set up Python 3.8 on my computer, and if you have the same version, then we both will have the same environment. Now if you use Python 3.11 or 3.10, there will not be too much difference, or even very little difference that you can even notice. But still, I would suggest that we use the same version. So I'm going to use 3.8.10. So you can just scroll down here, and 3.8.10, you can click on this one. Now you go down, and here's a lot of different options of how you can download it. We will download the Windows installer. If you have a different operating system, you can choose here too. So let's say Windows installer, and in the downloads I've created a folder called Python and I save it there. So we have it here. So once you have it, you double click on this one and it should open up something like this. It might be slightly different if you do not have a Python. If you do not have Python already installed. I already have installed. This is why it is giving me an option of this one, but I will choose this. So you need to make sure that all of these are checked. Everything seems fine. We click next. Now here are some options. You can um, keep the installation directory as it is, but one thing that you need to do is that you need to make sure that you check this one, add Python to environment variables. Like make sure you check it like this. Okay, if you do not check it, then you have to manually add this and that could be a hassle. So make sure that you check it here, then you install it. I will not install it because I already have it installed. Now after the installation, you need to verify if it is installed or not. Now there's two ways to do it. First is using a command prompt. To open command prompt and then you simply write pip dash dash version, hit enter. So if it shows something like this means that Python is installed, and if it shows some error like pip is not recognized, that means that Python is not installed correctly. Another way is that you simply go here and type IDLE, and if you see this one, this means that Python is installed. So this is the, if I open this one, this is the interpreter that comes installed with Python. So this is their default one. This is also software. We can write code here and we will be able to run the code, but we will not choose this one because this is very basic and does not have a lot of functionality. For example, I say print hello world and hit enter, says hello world. So this is like your first program. But let's just close this for now, go back and let's go ahead and install Visual Studio. So I will copy this here, go back, paste it here. So here you will see the download options. I will choose for the Windows. I will say okay, I need to download this. Let's download it in the same directory. Finish for it to download. Okay, it's downloaded. You can go back. So we have this VSCode here. Accept, next. We can just leave it as default, but you need to, you can keep it as it is. Click next, and then you click install. I will not click install because I already have it installed. So yeah, so once it installs, you can search here VSCode and it should look something like this. Click on this one and here you have VSCode installed. So this is basically VSCode. So first thing you need to do is that open a folder. So let's say we want to open a folder. So let's say I have created this folder code. I'll say okay, this is the folder. Select the folder and it opens it. Now you can see this folder over here. Now there is no file in the folder as yet. For example, this is the folder, so it is empty. So this is why I cannot see any files here. So I can create a new file. Let's say I want to create a new file. Click on new file and select file type. So I want to create a Python file. Hit enter. And this is our first Python file. You can also do file, save, and let's say first code and save. So this is a Python file. Now if we go back there, the extension is .py. This is the extension for a Python file. Now that we have set up everything, now let's run our first code. Not first, we already tried it in idle, but still, let's try out our first code in VS Code. So before you do that, you need to go here, View, Command Palette, and here you need to type Python select interpreter. So you click this one. So usually it should show up here, the Python interpreter, because we need VS Code to, we need to say that, okay, this is the Python that we're using. This is the version of Python. Because VS Code is also used to code in other languages, but for Python we say, okay, if you have a Python file, use this one. If you do not see it over here, you can enter the path, browse, and browse here and go to Python. If you do not know where your Python is installed, you can simply go command prompt. If you cannot find it, just write where Python, and you would probably use this one. Users in app data, local programs, and so on. So if I go here, copy this, and I go here, hit enter. So here is the Python, and I need to give the path of this file. Okay, so let's go back. I already have it here. It should appear for you too. Click enter, everything set up. Now to print something on screen, what do? We say print parentheses or brackets, and then we write whatever we need to print. So let's say hello world and this. So once we have it here, we need to save the file. Control S, save the file. We say run, and we say run without debugging. Okay, just do this, and here it is executed. Hello world. So this is your first Python program, and you have successfully installed Python, and you have written your first bit of code on Python. So congratulations for that. And that will be all in this lecture, in this video. So in the next lecture, we will start writing some code, start to get into Python, and we will build on from there. So until then, see you in the next video. Goodbye.